So welcome everyone. Thanks so much for joining us on this rainy, blustery night for another Ecology Action Center Better Building speaker series. We'll start the evening off with a land acknowledgement. Then I'll introduce our three speakers tonight. And then we will wrap up. We generally hang out together for about an hour, and speakers chat with us for about 30-ish minutes, and then there's lots of time for comments, questions, and answers afterwards for a great conversation. So if you have questions during the presentation, I invite you to write them down in the chat if you would like, or just make a note of them. And once we've wrapped up the presentations, everyone can unmute and we can have a great conversation together. The Better Building Speaker Series is taking place in Mi'kma'ki, the ancestral, unceded, and unsurrendered territory of the Mi'kmaq. We are so grateful to live in this place that has been home to Lanuu since time immemorial, and we honor past, present, and future traditional knowledge keepers. We honor and support Indigenous sovereignty and the peace and friendship treaties that bind us all in relationship. We recognize that African Nova Scotians are a distinct people whose histories, legacies, and contributions have enriched the part of Mi'kma'ki known as Nova Scotia for over 400 years. As an environmental organization working in these lands and waters, the Ecology Action Center is committed to upholding our responsibilities as treaty people and to working toward decolonization and environmental justice. Tonight, we're joined by Timon Bruulsema, Zahra Williams, and Sean Kelly, who will talk to us about studies on the potential for panelized retrofits in Nova Scotia. This was a project that was done in collaboration with the Ecology Action Center. And I'm going to invite my colleague Chris Benjamin to talk a little bit about why the project happened and what the goals were. And then we'll turn it over to Timon, Zahra, and Kelly to talk about the findings, and then we'll open it up to questions. Chris, over to you.
Thanks, Hannah. Hi, everyone. Yeah, I just want to really give a brief context of the project and how it came to be, and I won't take too much time on that, but it goes back a few years, and I think various energy coordinators and others at Ecology Action Center had noticed kind of the panelized retrofit method, which we'll talk about in detail, or our speakers will talk about in detail tonight. But it was, that from Netherlands, energy sproing, and it was kind of becoming a thing in other places. And that's part of our role, is paying attention to new things, new technological developments or innovations in energy that can help us get to a net zero situation, whether it's through efficiency or renewables or both. And so this was a way to retrofit certain kinds of buildings in a way that was less intrusive to the residents and that could yield really positive results. And there was a local initiative, the Recover Initiative, where people were getting really excited about it. And there were certain practitioners like Shauna Henderson of Be Free Homes in Nova Scotia who are really keen on it. So we wanted to look at a study on that. And we a man named Rodney Small, who's the executive director of One North End, when he found out about our interest, was kind enough to introduce us to the owner of VIDA Living, which is kind of a number of properties, rental properties, that aim for a fairly low rental rate and market in across Canada, but mostly in Nova Scotia. And they were also keen to learn about how they might use this as a way to save money and save energy, and therefore also money in their energy bills. And we applied for funding, and I say we, but it was actually before my time. One of my predecessors, Kim Fry, I believe, put the grant proposal together to the HCI 3 Foundation, which was a new funder in town, working through Efficiency Nova Scotia, but on kind of similar thing, looking at innovative opportunities to reduce greenhouse gas emissions through greater efficiency. And what we proposed was to study one specific property in Dartmouth and to get a technical study done of it using experts in the field, like an architect or engineers. And so that's how we began the project and put out the call for proposals. And the one we liked best came from ZAP Architecture, which was from Zahra Williams. And hence RDH Building Science got involved along with them. So I'll leave them to tell that part of the story. But I will note that as a fairly non-technical person myself, one thing I really felt missing from the proposal once I got into the work was the Canadian context. So we know this method originates from the Netherlands, but there have been a number of projects in Canada. Not yet a fully implemented one in Nova Scotia, although a number of studies before this one and during and after. But I really felt it was important to set the lay of the land to get a better sense of where we fit into the national landscape. And hence Sean Kelly became involved. And he was graciously available to kind of do a bit of a landscape study or a look at a jurisdictional scan, really, a look at what was happening in other places to create the part of the toolkit that was really the first part of it, introducing what's happening in other places. And I found that really enlightening for me, because I was aware of some of these projects, but it was nice to see it laid out in that context. And it made for a nice, well-rounded report that had a national look, the big picture, and then a specific case study of this property in Dartmouth and the potential there. So I think that's all I'll say on that. That's kind of what I wanted to outlay as the context. And am I handing it back to you, Hannah, or should I go to someone else? Maybe I'll hand it back to Hannah.
Thanks so much, Chris. That was a really terrific introduction and set the scene really nicely. So I will turn it over to the three of you, our presenters. And I think you have some slides to share. So I'll just say, take it away.
Hi, everyone. We do have some slides to share. I'm actually going to be the slide sharer. And I just realized, Sean, that when I share my screen, I'll just listen for your cues to go to next slide. So thanks for the intro, Hannah and Chris. I wanted to give a little shout out to Timon, who's actually joining us. So RDH is a national, or I guess an international company that really has major expertise in building science. And over the years, while the projects at ZAP have grown to be quite large in terms of scale, we often have questions that require subject matter expertise, and they've shown up and partnered with us on quite a few projects. And we were connected with Timon specifically, who's in California, and you're in the San Francisco area, correct? Because you'd had experience with panelized products before, which we had, but in a slightly different context. So this has been really, really cool. So we have literally like cross-continental experience. And then when Sean came on the project to contextualize, Sean brought with him from consulting background expertise that then I would say went vertically all the way up Northern Canada. So it's been an interesting team. We've had really interesting chats, and we're happy to share what we have developed for this, and we're also happy to have follow-up conversations. So I'm going to share my screen and go to full screen mode on this presentation. And this is a little bit of a stolen slide. This is the cover sheet. So for your context, if you see this image around, you'll know that you're looking at the toolkit, which is also available on the EAC's website, the link. So I'm going to hand it over to Sean, who's going to give us some context and background on the why and what so far.
Yeah, so I'll be quick here. Nice seeing you all. People have been talking about energy sprung and deep panelization for a while. There aren't lots, as Chris said, there aren't lots of examples of the work actually being done yet in Canada, but there are some out there, and some of them are really, really interesting. So I'm just going to quickly highlight a few. So Sundance Housing Co-op, they're a really interesting affordable housing co-op in the Edmonton area, and they got $2.5 million for deep panelization retrofits from Enercan to do 2 units, and the 2 units are now complete. And they want to do retrofits on about 37 plus more units, which is really interesting. So from their pilot, they've achieved 70 to 80% energy reductions. And they also added solar panels to meet 75% of their energy needs. So they are well on their way to being net zero. And they are looking to get $7 million more to continue this. The next one's also in Edmonton. The same company that worked with Sundance, which was called Butterwick Projects, they worked on a private home. So Jim Sandercock and Melanie Harmazma's retrofit. And this is the first private home that's been panelized with deep retrofit goals. And it was very, very interesting. They installed the panels in less than a day. Everything fit within the design tolerance. There were a few challenges along the way that had to be dealt with. So they said that project management was at times complicated because you have a lot of moving parts, and the panelization is somewhat new for a lot of people involved in this work. Due to the home's age, it's from 1951, which they say is a really old home, but of course we live here on this side of the country, so it's not that old, but it is fairly old, and there were some unexpected challenges that required remediation. And certainly the more technical friends amongst us will talk about that, but that is one of the concerns about panelization. As someone in an older home, you start looking into it and there could be structural problems or rot or mold or whatever, so you don't want to cover it up. So they had to deal with that. Also, their roof line caused a few challenges, but they got through it. They've achieved really, really good energy savings. And now there's several other single family homes in the area that are duplicating this PEER or prefabricated exterior energy retrofit process. So that's exciting. We have the Ottawa Community Housing. They have 6,000 units across the city. Their buildings are 1960s to 80s. They piloted one 4-unit block of townhouses, and they started the work in 2020. Now, what's interesting is they actually created an offsite factory, mini factory or facility to create the panels for these 4 townhouses. And they installed them. They added heat pumps, heat recovery ventilation, and it looks like these homes are going to be net zero emissions once the solar arrays are fully on, which I think they are at this point. So now they're looking at doing more homes, but this has been really successful. And then finally, there's also the Refrained Initiative. So this is a group that's working with the BC Nonprofit Housing Association, City of Vancouver, Metro Vancouver Housing Corporation, and the Pemba Institute. And they are doing deep retrofit designs on 6 buildings. And they've completed 3 of the initial designs. And this is designs on deep panelized retrofits. Or that was the original intent. I will say that what's interesting is only one of those plans recommends panelization, and that's partially because 2 of the buildings needed some major repairs, including recladding. They had some mold and structural issues that they had dealt with, and they felt that it made more sense to do traditional deep retrofits. So take everything off, put in the new insulation, the new cladding. They did find some contractors who were working on the projects were a bit uncomfortable with panelization because they may not have had those skills. And then there's always the issue of limited manufacturing capacity to build the panels that are needed. Next slide. Actually, well, you can say there. I just want to quickly say that there's a few other key initiatives and organizations. We don't have a slide for it, but there's Retrofit Canada. It's an open source project that looks at deep retrofit solutions, and they have a lot of case studies and info on deep retrofits and panelization. There is, of course, Recover here in Halifax. Recover is fairly well known. They started as an organization to really promote panelization. They've expanded now to be about deep retrofits, and they're involved in a very major deep retrofit project across the Atlantic. There's also Sustainable Buildings Canada. They've done a lot of research on panelization and the panelization movement in Canada. Just really quickly, and I'll pass it on. There's some challenges to panelization, and these are the more the non-technical challenges. This is some stuff I looked at. Obviously, labor shortages in the energy sector and the construction sector. It can be difficult for contractors to take the time or to carve out the time to learn any new techniques when there's so much work going on, and new builds are being prioritized. There's higher upfront costs for retrofit projects. They will pay back over a certain amount of time. They make economic sense in the long term, but like everything, upfront costs for a lot of us is the problem. That's why you have in Nova Scotia a lot of PACE programs, property assessed clean energy, where the idea is to pay up front and then you pay back over time. As I say, lack of skilled contractors and processes. There are technical hurdles, moisture control, air tightness. We have a lot of old housing stock with quirky additions and that in the Atlantic. And there's not a lot of incentives for deep retrofits. There's incentives for retrofits, but not tons for the really deep whole home retrofits. But of course, there is a strong case for panelization. You know, if it's done well, it can minimize the tenant disturbance with pre-built panels. It can be done quicker. They don't have to have their lives completely turned upside down. As someone who just went through a lot of retrofits on his house, it can be very disruptive. It obviously can reduce energy costs quite substantially, improve comfort quite a bit. And it obviously aligns with our climate goals to reduce our GHG emissions. So that was some of the jurisdictional scan and some of the non-technical challenges and opportunities that we found when we were doing the toolkit. So I will pass it over. Are you doing the next bit?
I think I'm doing the next thing. Yeah, thanks so much, Sean.
Sure.
I think that was a really good overview to kind of understand the history, what's happening in Canada, some of the organizations, and then some of the challenges that we have right now. So then that will bring us to the case study that we completed, specifically 54 Jackson Road in Dartmouth, Nova Scotia. I'm not sure how many of the folks on the call at the moment are in Dartmouth. I am in Dartmouth in downtown, or I guess in the Cove neighborhood right now. And this building really exemplifies a classic kind of post-war flat walk-up building. It's interesting because when we get to later slides, I'll give an example just in my neighborhood. As I traverse around, there's so many examples of this exact type of building stock. And we're in a situation right now where if we don't find a way to address them, due sometimes to deferred maintenance, sometimes just failure of exterior materials, enclosure materials, whether it be the roof or the exterior wall, we are in need of addressing them because they also provide a significant amount of the affordable housing building stock in Nova Scotia. So these are interesting for so many reasons, and it goes beyond just the conversation of climate and building performance. So this particular building was constructed in the 1960s. And there is significant heat loss due to inefficient insulation, and no control layers, no air vapor barriers exist at all. Originally, when we were talking about the possibility of a panelized retrofit, and we started going into discussions about, you know, how does it benefit? And this is an ongoing conversation that we have with clients. We talk about energy efficiency use, we talk about occupant comfort, obviously energy consumption and carbon footprint. But the thing that was interesting about this case study and this toolkit was, I'll say, the scalability of the project. Can we learn something here that can be repeated in a building footprint and massing that's quite common in, you know, not just the Nova Scotian landscape, all across Atlantic Canada, because you will, or I'll say Maritime Canada, because you'll see examples of this type of building stock in New Brunswick and Prince Edward Island as well. So I wanted to just give you a context. Funny enough, this is where I live, this is where I am right now, and this is where I work. So I am Dartmouth all day. And just if we were going to look at the downtown area of Dartmouth within the circumferential, which you are seeing here, there are at least 20 buildings that are similar to this form. Some of them are a little bit taller, some of them the footprint may be wider. They kind of all range from 12 units. As you'll notice, like the Killam, some of the Killam properties along here, there's 8 of them. They range from 12 unit to 20 unit buildings. If you come up to Gaston Road, you'll see again a whole community of this building stock. In the Albert Lake area, whole community of this building stock. And then coming down in North Dartmouth, again, you'll see this condition all the way up to Shannon Park. So just in, you know, within a 5-kilometer radius of my home, we're seeing a lot of this. And the data is showing that if we could address the issue of panelization, we could be potentially impacting up to 20,000 households in Nova Scotia. So then also on my way home, I thought I would capture an example, because on the corner of, I believe it is Pleasant Street and...
It's Pleasant and Portland.
Thank you, because I was going to say Maitland, and then I said, no, it's turned to Skokomal, and that's not the right one. So one block up, basically by 5 corners. This building, it's also apartment building, rental building, is being reclad, and it's been in the process of being reclad for the last at least 7 months. And so I bring this up as an example of the case for panelization, because the tenants have been in place the entire time. This is my neighborhood, so I walk past all the time, and I've seen the construction evolve. However, if we had taken the approach, and this is not a project that I'm involved in, I'm just in the neighborhood, if it had taken a panelized approach, one, we probably would not have been into the winter in terms of schedule, because the schedule would have been expedited. And 2, the duration, the length of time that it has taken to complete demo. Then they took the demo all the way back to the sheathing, the exterior sheathing, which they replaced. They're in the process of replacing the windows, and you can see they had existing aluminum, and now they've got what seems to be, I believe, black vinyl, but I'm not sure. I didn't go close up to it, but based on the frame thickness, I'm assuming. I think they're Coltec windows. And currently, the control layer has been exposed for quite a long time. And so these are some of the interesting things that are happening when we go alternate routes. So part of our study was to take the existing wall section of the building and imagine what that could look like. And so we did that by taking a look at a couple different panelized systems. We looked at concrete sandwich panels. And I will say in a situation like that, just based on the weight alone, would have been concerning. We looked at insulated metal panels, we looked at steel frame panels, and we looked at EFIS. And I'm currently looking at a large scale project right now where EFIS has been brought up by the client. It's a large residential apartment building on the peninsula, and EFIS is an interesting material for me in our climate. So what we decided to do was develop an illustration that could kind of speak to the conditions that would have to be addressed. So what you're seeing in the gray within the wall section, the gray part is the existing, I'll say condensed exterior wall, where we have a foundation condition. This is an idea of the floors. Again, exterior wall, the floors, exterior wall, and you can see where a window would have been, because in the situation of panelized, so overclad, we would have to extend that window buck, because in adding this new assembly to the exterior of an existing building, we're pushing out our insulation pane. So when we're pushing out our plane of insulation, we then want to have continuity, and we were recommending that the window be pushed out to be in alignment with the new insulation. And then again, that condition where in this case it was a flat roof. However, in Nova Scotia, this type of building stock can come with a hipped roof, a gable roof, I see gambrels and flat roof. So the roof condition changes, but essentially this is a strategy that illustrates kind of what we're looking at for a typical panelized recladding assembly. And I think one thing that's interesting to note is when you are applying this much weight onto the building, you're not only looking at how to fasten it to the building, but you're also asking questions about how the load is going to come down. So in this particular illustration, what we wanted to show was an idea, I'm almost going to call this like a curb, a foundation curb, or expanding the foundation footing to carry some of that vertical load to provide some more structural stability. So these are the kinds of things that you're thinking about: continuity of thermal barriers. You're thinking about structure, added load, wind capacity is definitely something that should be considered when you're dealing with an existing structure that never considered or contemplated having to carry this extra weight. But the interesting thing is about this is if we are to come to site with these as panels, as opposed to what we're typically seeing in our local marketplace, which is just demoing and then essentially going around the building in phases and applying new windows, new insulation, new fasteners and new cladding, the speed by which we could essentially install panels, you could be looking at maybe I'm just going to give an example, 20 feet wide and the floor is up maybe to 4 stories within a day, versus the amount of time that we're seeing recladdings occur right now. So some of the things that we do need to think about as we are adding a new system onto a building that previously would not have been very tight in terms of its enclosure. People often talk about buildings breathing. There's pros and cons to the term, but the idea is that with this older building stock, and you don't even have to go that far, right? Like within my lifetime, buildings, the enclosure was not as tight, and airflow and moisture is coming in and out the enclosure. The critical thing being that when you have the ability for air and moisture to pass through and dry out, it is not an issue. It is in tightening the envelope and trapping moisture in that we have major concerns. So moisture management becomes a challenge. And we see that in all projects. A lot of the reclads that we're doing right now, we probably have about 7 in the office, and often how much we insulate and whether we're insulating on the interior. We never go interior fully anymore, but some insulation on the interior, a hybrid wall, interior, exterior, or completely to the exterior, we're constantly doing WFI calculations and reaching out to partners to kind of verify where our dew point is in the wall. Structural attachments is also a major consideration. That is, how are we mechanically fastening this new cladding onto this new panel onto the existing building. And then the other item, and I think this is a really critical item in our context, is dimensional tolerance. Because with these building stocks, even though most of them are brick on the outside, they still actually are combustible buildings because most of them are wood framed. So the timing that they were built, 1960s, we're probably not even in the time of nominal sizing of wood. There's warping happening over time. There's curvatures. These buildings are typically not, rectangular in shape, and they vary both horizontally and vertically. So you're now looking at a situation where you're going to potentially fasten something that is dimensionally stable, that may not warp and change depending on the weather conditions outside, and it won't change over time, onto a substrate which is not dimensionally stable. So that is something that should be thought about, but also the tolerance of error that you have. Because, we typically would recommend, or not typically, we would always recommend a building scan, but then elements of the building are fabricated, they're coming onto site, being fastened together, and there's a point to which you can't accept any gaps or any tolerance of something not aligning, both with each other and the plane below. So those are some considerations. I'm going to pass it over to Timon.
Thanks, Zahra. Yeah, so we did a bit of the energy analysis on this existing building for the case study. So we looked at the historical utility data and kind of created an energy model based on the existing building to kind of determine targets for the upgrades and retrofits and establish the baseline there. As you can see here, the majority of our energy, and I'm calling this energy use intensity, so it's kind of the energy used in the building divided by the square footage, so that we can compare this to kind of other buildings as well. So the majority of our energy use intensity is kind of going to the natural gas heating. And when we break this down further, a lot of that is coming from the air infiltration in the building and the walls. And as Zahra mentioned, there's no air barrier. So that's where a lot of this cold exterior air was coming in the building and kind of driving up our heating usage. We can go to the next slide, Zahra. So after we kind of established the baseline and ran an energy model on that, we broke up the retrofits kind of into two phases. So phase one includes the panelized upgrades, including windows and a heat recovery ventilation. That's kind of the object you're seeing on the right here. It goes through the panels to provide fresh air into the suites. And we have to add this along with our phase one, because when we solve that air leakage problem that I was talking about, we're reducing the heat load, but we're also stopping that accidental fresh air that the tenants were getting. So we want to add mechanical ventilation to replace the fresh air that was being supplied through air leakage. So the panels will address some of the heat loss, but our phase two systems will also use this opportunity to kind of increase the mechanical efficiency. So you can go to the next slide. So in phase two, we're looking at these mechanical systems. So we can go from an existing gas boiler that is typical in a lot of buildings throughout the country, and trade this in for a central air to water heat pump. And the baseboards will be replaced with sweep fan coil units. The fan coil unit kind of takes the place of a baseboard. It just has an extra fan. And the combo of this air to water heat pump and fan coil unit will provide the heat, but they also have the addition of providing cooling to the suites where there was none before. The central air to water heat pump also can serve for your domestic hot water. So it's kind of taking the place of 2 gas boilers, one for the domestic hot water and one for the building heating. And these mechanical system upgrades are best paired with this phase 1 approach, because when we're adding the insulation and sealing up the building, we can actually use a lot smaller mechanical equipment. So the phase 1 approach can kind of be taken by itself. You're adding insulation, you're removing the air leakage and adding new ventilation. But this phase, so that can happen first, but then phase 2 kind of needs to happen to a building that's already been insulated further. Now we can move on to the results. So yeah, you can go to the
Sorry, I
next
seem to be,
slide.
oh, here we go.
There we
I was
go.
having a little bit of a technical issue.
So on the left, we can see the EUI, the energy use intensity, and we see the reductions from phase 1, where we're kind of reducing that natural gas heating column, and reducing the total energy by 25%. And then phase 2 builds on this to reduce the energy by 60%, which is pretty close to what Sean was seeing with these adjacent studies as well. One point here is that while we are kind of reducing the overall energy still, we're actually adding energy from cooling. So this 60% is a very significant reduction while we're adding another load of cooling. Now on the right side here, you can see the GHGI, which is the greenhouse gas intensity of these retrofit phases. So what we can see is that in phase 1, the GHG emissions come down because all we did was reduce the natural gas heating. But when we switch to this air to water heat pump, we're actually changing the building to a fully electrified system. And now we need to talk about Nova Scotia's electrical grid emissions. Currently, in Nova Scotia, the electricity actually has a higher GHG emission per unit of energy than burning natural gas. And this is because of the coal power in the electrical mix. So we can see this in the phase 2 option, where the GHG of the building actually goes up. But based on Nova Scotia policies, and we're already seeing the grid getting cleaner, we kind of estimate that this will actually be very significantly reduced by 2030. You can go to the next slide on costs. So as we've noted, these panel retrofits are very new, especially in Nova Scotia. So these costs are really a pretty wide range. As there's no precedent, we don't really know how much a contractor is going to charge if they haven't done something like this before. And for the manufacturing of these panels, they do likely need to be shipped from another part of the country. So we've estimated some of these prices based on similar projects, and we found that there's a return on investment of around between 40 and 70 years. This is a pretty high ROI. Typically, developers and owners are kind of looking for something around like 15 to 20 years for it to be be kind of a positive investment into the building. However, there's a lot of energy of other benefits here. So you can go to the next slide here. So beyond the energy savings of these, while the ROI is not attractive for most owners, the costs don't really incorporate the other benefits that actually greatly increase the building value and the living conditions for tenants. So improved comfort from added cooling and increased insulation. This can lead to resilience through future climate and more common heat waves that we're experiencing. Enhanced air quality coming from the air filters in the HRVs and reduced air leakage. And that can also protect us from smoke events and stuff like that. And we also have opportunities to rethink the exterior aesthetics, increased durability from the new building enclosure panels, and avoided emissions from not demolishing a building and just building new buildings when we have to look at updating their energy. Now, I think, is Hannah going to talk about this one, or are you there? Sorry, you're on mute still, but.
I was gonna say, or Chris or me, I'm happy to. So here's some of the key takeaways and really what we think is interesting, because panelization does offer a scalable solution for Nova Scotia's aging housing stock. And, you know, as we sit in a housing crisis, the other thing that it offers is a more expeditious process relative to the typical construction period to do a demolition and a reclad. We also, of course, have significant energy and carbon savings, which are possible, but as Timon spoke earlier on, there is some work that needs to be done in our grid in order for us to really benefit from what's possible. And I think that the 2030 plan is going to help there. But I think the other consideration and the takeaway is the benefit of pilot projects like this one. In order for the construction industry to really build confidence in this methodology, and for building owners to build confidence in this methodology, we need to be able to have projects where people can, one, see the process, but also see the benefit pre and post work being done. So what that looks like for us in terms of next steps are securing funding for large-scale retrofits. And earlier on, Sean mentioned the Recover initiative. They are actively working with nonprofit groups specifically to source funding. And we have a couple of projects in the works where we've done a very basic schematic, and we're hoping to be able to obtain enough funding in order to take the project through. Increasing contractor training and panelized systems. And one thing that I didn't note on this slide, it's not just about increasing contractor training. It may be about exploring some geographically specific options. For example, panelizations with wood frame, because that's the language that we speak in terms of constructability, or just adapting the concept to something that is more familiar with our trades. And then the final thing is encouraging government incentives to offset costs. We have a major challenge with our built infrastructure in Nova Scotia. And if we are not finding ways that go beyond private dollar to make investments, it's going to be where our building stock will be in a similar crisis to our housing crisis. So we do need support, and support needs to come from, multi-level avenues. So I think this is our final slide, and I think we're curious. We're curious about having conversation. We're happy to answer questions. We're curious about your thoughts on panelized retrofitting for local housing and the barriers that you foresee, either based on where you live or what you're seeing in the marketplace. And the final thing that we're curious about are there any buildings that you think we should explore? So I'm going to stop sharing just so that we can see everyone's faces, but I will note Sean, Timon, and my contact are there if there's burning questions that you want to ask beyond this evening's discussion. How do I stop sharing? Here we go.
Thank you so much, Zahra and Sean and Timon. That was really interesting to hear the toolkit come to life as you were talking about all of those different aspects of the research and the work with the demonstration project. Feel free to turn your cameras on if you like, your mics on. If you have a question, you can pop it in the chat or just wave your hand around and we'll come to you. Or if you have any responses to the questions that were asked.
Yeah, I've got a few items.
Yeah,
It's a great
Nigel,
presentation. I love this type of stuff, and we know that, you know, I've heard this quote many times, that 70 to 80% of our current building stock will be still around in 2050. So we've got a big job to do to scale up. And I think the scaling up is obviously a very key ingredient to it. I don't know if anybody's got any thoughts about the scaling up. I'm going to post a sort of link. I wish I had a presentation here from this company out of the UK that are using high-end manufacturing techniques in a factory base. They're using advanced sort of manufacturing systems to make actual panels and make them actual sort of, also, you know, taking into consideration embodied carbon as well as a big part, because we know as we reduce the operational carbon in buildings, we know that we've got a growing problem with embodied carbon.
Mm.
And so this company is using hemp cell in their actual panels for insulation, which actually stores the actual carbon in you know, that's sequestered during the growing of the crop. So I just think it's a very big subject, but we've got to think very sort of lateral in how we scale up and how we mitigate issues with the emissions factors with the grid, with using sort of biogenic materials and use that sort of carbon offset to you know, mitigate. And we know the grid's going to get cleaner, but there's still a question whether we will be at 80% renewable at 2030. We all hope that will be the case, but there's still a lot of things changing out there, and we don't know whether that will be the case. But anyway, yeah, I just wanted to share this company because I think they've got it right in the terms that they're going to use factories to build, and not only factories, but portable factories that can go to site and actually build and panelize on site. So I've seen videos where they can take these milling machines in shipping panels, take them to an actual site and actually do the assembly there and then. And actually, with that actual panels coming out of the machine, they're also being labeled so they can build them up in sequence as well. I wish I could share the presentation with you because the actual website doesn't really do any justice on the presentation. But I think it's a big topic, and my points is the key is scalability and how we do that. And I think we've got to be pushing the government and investing in sort of factories to be able to do that. And you can hit two birds with one stone. You can do the panelization, but you can also start building affordable housing in factories. And using, you know, you've got to establish a supply chain that's using biogenic materials. Like if we start growing hemp, we start using wood fiber, whatever it may be, we can bring that into a supply chain so you can localize those sort of those factories. And that's just the point I want to make. I don't know if anybody's thought about that or whether, you know, that is the next step. Or I know there's some work to be done in terms of just try of proving the point with the panelization. There's a lot to be done there, but the next step really is, I think, is trying to scale up. That's the point I was trying to make. Sorry, I waffled on about that.
Oh,
Not at
thanks
all.
so
Just wanted
Actually,
to-
that was a great share, Nigel. I think what's really interesting about that product, with energy building systems, what you'll notice is if we think about a panel as an aggregate, what they've actually done, and I think that probably has to do, you said it was developed in the UK?
Yes.
So you're dealing with a building stock that's of a scale that makes sense to have a smaller aggregate, making it a lot more flexible. A lot of the panelized systems, and I'm not talking about panelized systems that we would use to reclad a building, but a lot of the panelized systems for new construction, the scale of them that we use, and we see them in a lot of, industrial buildings, tilt-ups,
right.
they are very large and they don't lend themselves to adaptability to the dimensions of a typical, post-war home. So this product is actually interesting, and you can see even the way they have looked at joinery, joining in a traditional carpentry method. It's very interesting. I'll do some more digging. I'll have to share that with the
if you put your email, I'll send you the presentation.
Perfect.
They're also thinking about circularity as well. They're trying to kill a lot of birds in two stone. They're talking about scalability. They're talking about using biogenic materials to bring the embodied carbon down, and they're using the way the panels have been fitted so that it can be disassembled after 60 years and be recycled. So they're trying to kill all those things in one go. Yeah.
What's the term, Timon?
Circular economy.
Thank you. Thank you, Timon.
I'm just going to quickly say I'm doing a little bit of work up in Nunavut, and a lot of the housing is really not great, and there's a desperate shortage for housing. So they're building houses, and most of the communities, everything has to go up on a sea lift. But panelization could really work up north, like specialized prefab panelization. Scaled, optimized for that community, scaled to fit on the sea lift. So there's a lot of, it's not really being addressed or looked at, I don't think, but it could be really interesting. Because right now, to do retrofits on the existing housing that's from the 50s and 60s, it's really challenging. You can't really do deep retrofits. There's mold and mildew and there's moisture issues, so it's pretty complicated.
Thanks, Sean. And thank you so much, Nigel. Could you send me that link to the presentation, Nigel, and then I can send it to everyone who's on this call and also the people who had to leave early.
Sorry, I'll send you in an email.
Okay, that'd be great. Yeah, thanks.
Okay.
George, did you want me to read it out, or would you like to go ahead? George is, okay, sure. George is saying that the 40-year ROI is a tough sell. How does that compare to the costs of the site-based retrofit in your neighborhood, Zahra? That was taking, 7+ months, will probably be a full year. And I live just down the street from that, at the very beginning of Pleasant Street, so not too far away, and also walk by it on a regular basis, and have been chatting with Ross Cantwell, who knows about that, and just talking about some of the costs involved. It's so expensive to do that work. So I'm curious to know about that ROI,
so
how it compares.
Again, it's kind of hard to say exactly how much the panels are. I wouldn't say they're more expensive than doing like the demo and replacement of cladding. What there is with the panels, there is an opportunity for a lot of cost savings. If somebody has the experience of working with them, where you can save a lot of time on site. So it's saving in labor costs and in tenant relocation and stuff like that. So there are opportunities for cost savings. I just don't think that we can kind of push those on people right now, because it's not really guaranteed if you don't have all of that experience with the paneled systems.
Absolutely. I think the current labor market, we have to remember how local construction companies price jobs, and there is a complexity pricing that exists, and that relates to both building geometry, that relates to introducing new building systems and technology into your project. So the more economical projects in Nova Scotia tend to be buildings with regularized forms, as in not lots of geometry and jogs, and tend to be with building systems that the labor market is already familiar with. And right now, where our construction industry is so busy and we have huge supply issues, what actually happens is when you have a project, unless you can get buy-in from a construction team early in, there's a possibility that you won't even get bids. And so we're currently in Dartmouth, there is an office building on Tacoma, and that's going to be converted to affordable housing, 70 units, and the province got behind the project. The drawings are almost done. We're almost to tender, and we explored different options, and based on availability, based on the schedule that we had, there were also some other challenges, cranes, etc., things like that. It was decided, and the building was almost completely vacant from as an office building. It was decided that we would, gut and reclad. It was my hope that this would have been a panel option, but there's also the challenges of getting a client team on board as well, because it's unknown. And the final thing, which we probably didn't talk about, is financing. New systems in our market, new building technology, new systems can sometimes be more challenging to get financiers behind, because there's an element of risk. And one of the largest elements of risk, and we saw that when things like the Hambro system, a structural system, came online. That system had been used west in Canada and in the States for a long time, and it was brought to this local market because of discussion around expediting the construction schedule, and it did not expedite anything, because when it was brought on site, people had to learn how to use it. In addition to installing it, people had to learn, other trades had to learn how to engage with it, I'll say. So one of the values of a Hambro system is that instead of having a concrete slab, which a significant amount of our residential multis are, new construction, it's essentially, think of like an open web steel joist. So you can run mechanical and electrical conduit and ductwork through it. Well, we have multiple projects where the Hambro system went up and they still ran the ductwork and the conduit below it. So there's a lot of like complexity to training, to mastery of skill set that goes beyond, and financing is something that we didn't talk about earlier on, but that is a huge part of the decision-making process that a lot of our clients are using as the go, no-go for new technology.
One more point on that sort of thing, and just on the scalability towards like 2050 goals and things like that, is like, I guess the best way that we want to think about things like this, especially with a long ROI like that, is that when you're kind of thinking about replacing your building's systems, like if you need a cladding replacement anyway, or if you need an upgrade in the mechanical systems, that's when you want to kind of try to compare these two options. So if you have a big capital expenditure coming up anyways, maybe that's when we want to look into something like this. So
right, because you need to make an investment anyway.
Yeah.
Well, one of the challenges is
every building kind of needs a plan.
Yeah.
When you're planning for one of these in the future, that's kind of when you want to look into the panelized systems and mechanical upgrades as well.
I was just going to quickly say, one of the challenges is that people don't think about that until there's an emergency in the home.
Yeah.
So, you know, your heating goes, or there's a major structural problem, and then you're scrambling. So that's one of the logistical challenges that's going to hurt us.
Yeah, I think that the as you're saying this, you're reminding me of another conversation that we had, and that's the social justice element of our climate is changing. It's becoming a lot hotter, and it's no question that if you were to survey the building stock, many of the residents who don't have the ability to be in control of their heating and cooling in their building are people who are on the lower end of the income scale. So you know, when we talked about their other benefits or their other considerations beyond ROI, this idea of living with dignity, of having the tools and the access to be able to control your environment, this is a huge consideration for that. I mean, I know, Timon, you may know the science behind it. We are putting in a lot of the Innova products. It's essentially a through wall, you know, a through wall system that allows per unit you to have heating and cooling where otherwise there would have been a central system. And more people are asking about the question. While previously, from a sustainability standpoint, we were always talking about fresh air and passive means, the ability to cool your space is a huge factor to day-to-day living conditions in Nova Scotia, and it will only get worse.
We need to convince the Efficiency Nova Scotia and others maybe to pilot a panelization project in home warming.
Okay.
Something like that, like a deep retrofit on a home warming home to see how it goes. It would cost more money, but like you say, who needs relief from energy bills more than lower income or those of it historically marginalized? Just a thought.
Absolutely.
I recently met I think the manager of the home warming program for efficiency and at an Energized Bridgewater event. So be happy to take that idea along and connect you all. I think that's a
Please
really
do.
smart idea, Sean.
Please do. Yeah.
Yeah, home warming, just quickly, we used to have, you know, about 6,000 per home, but that, you know, with the latest efficiency agreement, it's gone up to like about 10 or 12. But if we can keep that going, and the idea of a pilot of something deeper would be really interesting.
It's just after 6:30. But if anyone has any, you know, really pressing questions or feedback you want to share, we could probably stick around for another couple of minutes. If not, we will take the time to say thanks. So does anyone have any other questions or thoughts?
No, I just thank you. A great presentation. I'm glad to see there's a big cohort of people, or I wouldn't say a big cohort, but there's a cohort of people that are trying to tackle this problem. And you're right, Zahra, that the cooling is going to be a big impact, especially for, you know, as we go on in the next 10, 20 years, and especially for seniors that need that sort of protection from the you know, need that cooling effect is going to be huge. Yeah, and nobody seems to be switching on to that at the moment.
No, yeah. Well, I just want to
No.
thank the EAC then for one, giving us the opportunity. It's really nice to collaborate, and it's really wonderful to be able to explore and investigate what I would consider to be a best use option, as opposed to, you know, lowest common denominator or most economical. And I think, you know, if we think of all of us on the line as being champions for climate and champions for, you know, justice, then whenever an opportunity comes about, you know, use the toolkit as a conversation piece for what could be.
Mm-hmm.
I put a link to the toolkit in the chat, so feel free to click on that. You can download it. That will take you straight to the Ecology Action Center webpage where the toolkit lives. And I also put a link in the chat to the Recover Initiative, so you can read about the big and ambitious deep retrofit project that they're undertaking in all of Atlantic Canada. And as Zahra said, if you are aware of any buildings in your neighborhoods that you feel might be a good fit, please feel free to reach out to Zahra, Sean, and Timon about that, and they'd be happy to chat with you about that some more. So thank you so much for talking about this project. Chris, thank you so much for your introduction. It's been really lovely to have you here with us. This is our final Better Building Speaker Series presentation for 2024. And this is also our last, for now, virtual Better Building Speaker Series presentation. That started during COVID, and we're well beyond that now. So we're happy to report we're moving to an in-person model in the new year. There'll likely be a quarterly presentation. We haven't decided on an absolutely final model yet. It's in the works, but we will keep you posted. So please stay tuned. Subscribe for the Culture of Efficiency newsletter if you haven't done that already. Or if you get the Ecology Action Center newsletter, you'll find our updates there. Thank you again so much. I know some of you have joined a number of our conversations this year. It's really nice to see your faces on a regular basis and get to see you in person outside of these events. So thanks again for joining us. Have a great rest of your night, and we'll see you soon.